Hi everyone. So today I'm going to talk about the second milestone of our data mining assignment, which is to store data into a HIVE data warehouse. Let's go back a bit to our background. So from the milestone one, we were actually trying to crawl some real-time data from a certain source, and for that we have chosen the Star Online news portal to crawl the latest news from the Star, and we save our data in a CSV or Panda data frame from milestone 1, and for today we actually want to extend the functionality, which is to store the data into a HIVE data warehouse for further processing. And a little bit information on our system. So I'm using here the host operating system is Windows 10, and there are actually many ways to set up a HIVE data warehouse and a Hadoop system. My teammate has set up everything on a local Windows system, and from my end here I've tried doing installing a virtual machine, which is VirtualBox, and then I downloaded the Hortonworks data platform, the HDP on Sandbox by Cloudera, which includes Apache Hadoop, Hive, and also Data Analytics Studio, which I'm also going to show in a while. And then of course, as usual, like we are using the Python, and I'm using like Anaconda Jupyter Notebook to do the functions. And then for this milestone, we are also working with a shell command through using Linux through a browser. And then like the preparation for our HIVE data warehouse. So I've installed the VirtualBox and then also the HDP sandbox. And then I need to change some permission on the HDP sandbox itself. Especially the first one is to change the default host value from the existing one to 0000, which means to accept traffic from everywhere. And then also I need to turn off all the authentication on HDFS, Hadoop, and also Hive. These two can be found on respectively on HDFS site.xml file and also the Hive site.xml file. And then also the few additional libraries on Python. One is Impala to access Hive from Windows, and the second one is HDFS to create a HDFS connection. And the other part is to prepare the database schema and structure. So for our case here, we actually try to create a simple one for this milestone. So here is a sample from our data, including the like news ID, the date, time, category, headline, and URL of a particular news that we crawl from the Star. And then we created like a database called data mining, and in it we created also like a new table called my news with corresponding column names which correspond to the data structure that we have. And this one is the SQL syntax that we use to create the database, to create the data. We have like several remarks there. One is like to add in the row format delimiter and then the field terminated by the comma. This one is like the CSV format, and then to store the data as a text file so that like there won't be any error because of like different file format. And also we added in like to skip the header line count, the first line, so that when we read in the CSV table into Hive table, the first line, which is the header, could be skipped, and then we get only like the data itself. And then also another small function twist that we have done on Python, which is to store only the unique news into the Hive database. And now let's go to some demonstration. So I will start on this VM VirtualBox from Oracle. So I've installed from my end here a virtual machine, and then to add in and then I've also downloaded the Hortonworks sandbox HDP. And when I started the HDP, so we'll get this one, like it's a sandbox, so everything is like isolated, and then we can access the sandbox on our localhost browser just using the one of the command here. Like for VirtualBox, we are using localhost 4002 for the SSH. That means it's like for the Linux shell, and then the the dashboard is actually 8080 port. So this one is our dashboard. Like starting up itself, it took about 10 minutes every time. And then like we have inside here the HTTP sandbox, basically everything that we need, like HDFS, Hadoop, and then Hive, MapReduce, Yarn, and then also the data analytics studio, which is very helpful. And several things that I want to highlight. One is like the Hive is using a default MySQL server, which is very helpful for our case. And then the data analytics studio, they have a they have a user interface for data analytics studio, where we can see all our existing like databases and also the tables. For example, I've created a new data mining database, and then inside there I created my news table, and then we can also preview our data inside the database. So here is like, for example, there are some data inside now, and then like we can also compose our SQL statements directly on the server. This is very good for trial and testing. Like let's say we select everything from my news, we need to select the database here, or we add in like the database from in the SQL statement. So and when we execute it, we can actually see the result immediately, like there are some structured data inside our database now. And then so this is the data analytics studio, which is very good for testing and trial. And then the second thing, so we have, oh yeah, this but here they have like the user interface got several file view, like the several interface, so we can either see everything like in the configuration directly, or we can also, there's also a file view system where we can see the directory. Like for example, I've created a new subdirectory like under user, admin, and data mining. Here is where I store all the temporary CSV files with the crawl data like in the HDFS system. And then this one is the shell command, called the command shell. So we can access the localhost with the port 4200, and then log in using, for example, root and the password. So I will start it all over again, like from here. So like we can actually see what are the like the directories, like all the files that we have. It's basically the same thing here in the shell command type. So I can also like go into Hive and then to access the things directly in the shell. For example, now I've started Hive, and then I want to show the data that I have in the table of my news. So like if for example, when I show the databases, and then I can see here are the few databases that I have, and then I will use the database that I created, and then I will show the tables. And we can, for example, we can see like so far there's only one table in this current database, and then I want to show everything that I have from the table my news. Like for example, here we can see now like the latest, here are some of the latest items, and then we currently have like 99 rows inside this table. And then let's go to our Python program. So this one is like basically an extension from our milestone one. So we have like several additional libraries like compared to our previous milestone. So this one like we have Impala and then HDFS, we basically created a session class. This one is to connect to our Hive and also a HDFS interface. And then with the existing crawling function, so we have expanded our function such that like the data frame, like every crawl will get the crawling like every 300 seconds, which means like 5 minutes. So every 5 minutes we'll crawl the news one time and then check and see if there's any unique value. Like for example, if there's any new value, so the new value will save in a data frame df, and then if there's any instance or if there's any new entry, we'll save the df into a CSV file. And then by creating a session, we also use this connection like HDFS connection to store the CSV file into the Hadoop HDFS. And when we, at the same time, we will use the load command to insert the CSV file, like to append to our news table. And then this CSV file will be deleted automatically. And then like we repeat the loop every 5 minutes to crawl the data. So if let's see some of our latest code data. So like we have here some data. This one, for example, is the one that we just crawled. Like for example, we have, because I just started it, so we have like here the news ID, the published date and time, and then the published time, category, headline, and also the URL. And then this data will be stored on Hive. And let's do again like select. So the Python program is currently still running. That means that every 5 minutes we'll check whether there is something in whether there are new items coming out from the star. So for example, we see this one is it was 2 minutes ago, and so by next crawl it should be saved into our Hadoop HIVE data warehouse. And yeah, so basically that's it for our milestone 2 assignment. Thank you very much.